Welcome to The Explainer. Today we're going way beyond just talking about single AI tools. We are diving into the blueprint for building entire offices. You heard that right, even whole companies staffed by teams of AI agents all working together.
So the big question is, how do you actually pull this off? A single AI agent, no matter how smart it is kind of like a solo genius. But to solve the really massive, complex problems, you need way more than that. You have to build and manage an entire team, a whole AI office where these agents can collaborate.
All right, first things first. The most fundamental decision is structure. I mean, every office needs an org chart, right? An AI office is no different. So let's take a look at the different ways you can organize an AI team, because how these agents talk to each other is absolutely crucial for getting anything done.
So on one hand, you've got the classic hierarchical model. You know the drill, your typical corporate ladder. There's a supervisor agent who delegates tasks, which keeps everything clean and accountable. But here's the huge weakness. That supervisor is a single point of failure. If the boss gets stuck, the whole team just grinds to a halt. Then on the other hand, you have the swarm model. Just picture a chaotic, leaderless brainstorm. It's incredibly resilient because there's no single point of failure, but it can easily just dissolve into endless, unproductive chatter, with agents just agreeing with each other in circles and going nowhere.
Okay, but what about tasks that are super repetitive? For that, you've got something called MapReduce. Let's say you need to analyze every single stock in the S&P 500. Well, an orchestrator can just create 500 copies of a financial analyst agent, give each one a single stock to look at, and then pull all the results together at the end. It's basically the ultimate AI assembly line.
This slide shows a really key difference in management philosophy. Over on the left, orchestration is all about active management. Think of a central controller, like this traffic light, telling every single agent exactly when and what to do. Now on the right, you have choreography. This is more about setting up a system of rules that all the agents just follow automatically, kind of like a traffic circle. There's no central boss, just a shared protocol that keeps the whole thing moving smoothly.
So what's the bottom line here? Well, there's no single best management style. A hierarchical structure is going to be great for a predictable project, but a swarm is probably better for some creative brainstorming. It's all about picking the right org chart for the specific job you're trying to do.
So now that we've got the team structure figured out, let's zoom in a bit. Let's look at a single employee. How does an individual AI agent actually think, act, and, get its work done?
The most basic process for an AI is something called the react loop. It's a really simple but incredibly powerful cycle. So first, the agent thinks about the problem. Second, it takes an action, like doing a Google search. Third, it observes what happened. What was the result of that action? And finally, based on that observation, it thinks again and just keeps repeating that loop until the task is complete.
But, simple loops aren't always going to cut it. For more formal, predictable business processes, you have something called LangGraph. It basically turns an AI's workflow into a corporate flowchart. And this allows for these critical if-then loops. So for example, you can build a rule that says, hey, if the coder agent's code fails a test, don't move on, send it right back to be fixed. This is how you create super reliable, repeatable processes.
And that brings up the absolute need for resilience. I mean, what if the power goes out in the middle of a task that takes hours? Well, durable execution acts like a built-in auto-save feature. The system remembers every single step, so if it crashes, it can just reboot and pick up exactly where it left off. For critical jobs, this isn't just a nice-to-have, it's absolutely essential.
Finally, there's this really key trade-off in how an agent works. The React model we just talked about works step by step, which is flexible, sure, but it can be slow. A newer approach, called Rewu, has the agent create a complete plan right up front. This lets all the steps run in parallel, making it way faster and cheaper. It's really the difference between figuring it out as you go versus having a perfect blueprint from the very start.
Okay, think about it. An office where nobody remembers what they did yesterday, it would be totally useless, right? Well, by default, AI models are stateless. They have zero memory of past conversations. So we have to intentionally engineer their memory. This is how we build the company brain.
And it's not just one type of memory either. We can actually engineer different systems that mirror human memory. We're talking everything from short-term notes and daily logs to a huge company library, and even a sense of what's important. Each one serves a really unique purpose.
So first up is working memory. This is the AI's immediate scratchpad. It's basically the context window of the prompt. It's what the AI is thinking about right now.
It's very high resolution, but it's also really limited and gets wiped clean. It's the sticky note you throw away after you're done with the task.
Next, we have episodic memory, which is like the agent's daily work log. Now, this is a huge leap in capability. By reviewing its own past actions, the agent can see what it tried before, figure out why an attempt failed, and then self-correct its approach for the next try. This is literally how an agent learns from its own experience.
Semantic memory is the company's shared library. This is how we give an AI deep, specific expertise. It's a massive, long-term knowledge base, usually a vector database, that the agent can check anytime it needs a specific fact. It's just like an employee looking something up on the company wiki.
Then you have procedural memory. Think of this as the company's best practices handbook. It stores all the how-to guides and templates for specific jobs, making sure the AI performs its tasks consistently and correctly every single time. Now here's a more advanced and frankly fascinating idea, the emotional bank. With this, memories are weighted by how important they are, and just like in the human brain, they can actually fade over time unless they get reinforced. This is a really powerful system for helping the AI focus on what truly matters and just ignore all the trivial details, which stops it from getting bogged down in useless information.
Okay, so we've built our AI office, we've got an org chart, we've got individual workflows, and we've built a company brain. What's the big takeaway from all of this? Why does any of it matter?
So here's the crucial point. The future of AI isn't about building one single giant superintelligence. It's really about designing and orchestrating effective teams of specialized agents. Everything we've just talked about, the org charts, the workflows, the memory systems, these are the actual architectural blueprints for the next generation of AI that will solve complex, real-world problems.
And that leaves us with one final fascinating question to think about. As these AI offices become more and more efficient, maybe even more powerful than our own, what are the first great challenges we should ask them to solve? That is definitely something to chew on.